Hello guys and welcome on Blue Ammo. Today we're gonna review the pandas library, which is very used in data analysis. The main class of the library is the data frame. You can think the data frame as a table with rows and columns. The data frame is a data structure that can store heterogeneous tabular data, so it means that the columns can have different types. It implements many methods that are very common and used in data analysis, and it's very convenient to use. It takes time to master all the methods that the class allows, but you can start from the simple ones. To initialize a data frame, we can pass in some data manually, but by far the most common way is to use one of its methods that read from external data sources. There are in fact the read CSV method, the read SQL method, the read JSON method, which are very common and allows us easily to read from CSV, SQL databases and JSON APIs. So looking at the documentation, we see that a data frame can be constructed very easily using a dictionary in which we define as key the name of the columns and as values the list of the values we want in the columns. Then we apply the data frame construct, passing in the data argument with the dictionary, and we have an instance of a data frame which has some labels for the columns, some data in the values in the matrix, and this first column is the index. The index of the data frame is very important to understand. It gives a unique reference to a row of the data frame. The index can be modified and we can do manipulations on it, but a data frame always has an index. If we don't pass the dtype argument, the types of the columns are inferred. If we pass this argument, pandas tries to apply this particular data type to all the columns. First of all, being an external library, we have to import it. So if you already don't have it, you have to install it on your system with pip. So you have to pip install pandas. In my case, the pandas library was not present because I'm using Miniconda, which is a smaller version of Anaconda library. So with pip install, I installed the library. Now I can import it. As a convention, we imported the pandas library with the alias pd. So we can try now to generate a dictionary with some heterogeneous data. So this is our dictionary D, from which we can start building the data frame. Now, as a convention, we call the data frame df. We see that it's very easy to create a first data frame. We have a table with rows and columns. We have 3 columns, and for each of the columns we have defined 3 values. The data types are very different. We can inspect this with the dtypes attribute of the data frame. We see that the first column has been recognized as an object, the second column as an integer, and the third column as a float. Clearly, I cannot enforce a single data type on this kind of data. So if I try to do it, I see that the third column gets converted to integer, which may be not what I want, but the first column remains an object. Changing the third column to a float without the 0.0, we see that it is no more able to convert it to integer, but it remains of type object. If we remove the enforcing of the data type, we see that the third column now gets correctly parsed as float. So we have to be careful when using the dtype argument because it can mess around with the data types if the data frame is heterogeneous in data types. One very common attribute I use it's the columns attribute, which gives the column labels of the data frame. We see that applying the list constructor, we can have the list of the columns, of the labels of the columns. Another useful attribute is the shape attribute, which returns a tuple representing the dimensionality of the data frame. So in our case, we see that we have 3 rows and 3 columns. One very useful attribute is also the empty attribute, which returns true if the data frame is empty, so has no data. So it has been defined, but with no data. In our case, is false. Another useful attribute is at, which allows us to access a single value, specifying row and column. So in our case, with this data frame, if we want to access, for example, this element B, we see that it's located at index 1 and column 1. So we can do it like this. And we see that we got B. This allows us also to change the value at a specific position of the data frame. So let's say that we want to change this value into E. So we simply assign it, and then we print again the data frame, and we see that in that position now we have E. A common way to access the values of a data frame is using the iloc attribute and the loc attribute. These are very powerful and will be the object of a separate video. What I want to say now is that they allow some data analysis operations that are common also in a relational database with SQL language. So this concludes this short introduction on pandas data frame. There will be a separate video on the main methods of this class. I hope you enjoyed the content and I hope to see you here next time. Thank you.